There we go. Is that right?
I think so, yeah.
Okay. I gotta put this away someplace. I want to make that go away down here. There we go. What are we thinking? In the age of AI. Hi, everybody. I'm Michael. I'm this one. I'm wearing the famous stochastic parrot shirt today. It's the end of the day, so and there's no reception tonight, right? So I'm not between you and beer. So put your feet up because we're going to be here for a while. Oh no! All right, how are we doing? Can we make it happen? Can we put this on the right screen? Oh, not even. There we go. Good. There you go. Focus over there. Yeah. All right. What are we doing here? This is the keynote bit. This is a bit where I explain what the keynote's all about. Testing is and has been for a long time, under threat from people who are obsessed with technology. Now, it's not exactly surprising that software people are obsessed with technology, is it? But we got to remember the fact that we are here to provide service to people. We are here to serve people and people's interests first. The wonderful thing about programmers and developers is that they link the world of humans with the world of machines. As testers, we've got another job to do. As testers, we've got to link the world of human and the world of machines that the testers are creating with the world of doubt. We've got to help defend the business against problems by identifying those problems before it's too late. That's what we're here for. But over the years, it seems to me with the rise of DevOps and with the rise of automated checking and with the rise of a whole bunch of stuff that is really, really fascinating to people who program computers, we're now defending against risks to the build instead of risks to the business. That's been the big thing. And that's why we've got to learn about automation. That's why we've got to learn about AI to help our clients defend themselves and their clients from trouble and from potentially foreseeable misuse and from expense costs. Any kind of AI product. I'm going to talk mostly today about AI in testing, but any kind of AI product is never just AI. There may be multiple machine learning models inside a system these days, and that provides us with opportunities not to treat the whole thing as a black box, but to set up various kinds of tooling and various kinds of probe points and data collection and all kinds of stuff where we don't need to worry as much about the mysterious AI part, but we do, because we can't understand it. We don't know what's going on inside it. It's been built with no human knowledge of how particular algorithms were selected by a bunch of machine learning algorithms that ran a bunch of other algorithms and then chose the best one from all the different pots of boiling spaghetti. So what we got to do to test this is monitor stuff coming in and going out, because the stuff on the inside is sort of, kind of, a little bit, mostly more or less hopeless for reasons which we'll see later on. Understanding that black blob that was in the middle of the diagram there might help. Knowing what kinds of forms of AI are being applied, and there's lots of them. There's lots of different kinds of technologies that are referred to as AI, and there's a whole bunch of those different kinds of things. For those of you who are interested in deeper reading on this, there's a wonderful book by a guy named Simon Prince called Understanding Deep Learning. It's insanely expensive. It's like over $100, but it's beautiful. It's a really, really beautiful book. And then as soon as I had paid for it, almost as soon as I had paid for it, I found out the guy's got an ongoing PDF of the whole thing online, and but I felt really good about paying him money because it's such beautiful work and so thoroughly described. And there's lots of deep math in there, which if you're like me and certain kinds of math don't come entirely natural to you, it's hard work to go through it, but it's really worth it and really interesting and really like a physically beautiful book. So you pay your money too, if you're working. For large language models and GPTs, Matt this morning tried to give a thumbnail description of it. He didn't do too bad a job, I would have to say. But if you want a more extensive and more expansive kind of description of it, a great piece to look at is Stephen Wolfram's "What is ChatGPT doing and how does it work?" It's nice, above a person off the street description of it, but perfectly good for testers and people in technology. If you want to go deeper than that, there's a guy named Ben Levinstein who wrote a 5-part blog series called "What is ChatGPT?" Called "The Conceptual Guide to Transformers." Another really good thing to read, though, is Rodney Brooks's article in it was in one of the IEEE magazines, if I remember right, called "Just Calm Down About ChatGPT 4 Already." For those of you who are into development, look at Jessica Kerr's piece on a developer starting point for integrating with LLMs, and a really interesting and insightful piece of work by Chelsea Troy called "How Does AI Impact My Job as a Programmer?" One of my favorite articles on this subject, and it came out actually before ChatGPT 3 came out even, I think, was an article by Emily Bender and Timnit Gebru, and I forget the Macmillan Major's first name, but also Margaret Schmitchell, who was working at Google and was not allowed to publish papers under the name Margaret Mitchell. So Margaret Schmitchell was the author of this one on the dangers of stochastic parrots. Can language models be too big? There's also some really good stuff from Deborah Raji on it's a funny thing called, I think it's called Grover and the Everything in the Whole World Museum. Actually, that's what the book is about. There, for those of you who get the notes later on, a reference to that book. It's why it's over my shoulder all the time when I'm broadcasting from home. What are we doing as testers? We got to get back to that. As testers, we are exploring facts and evidence and inferences and assumptions and premises. What we're doing is we're examining beliefs about the software. We're examining beliefs about our products, some of which are harmful because they're wrong. And we're trying to move from weak assumptions and weak inferences towards stronger stuff that we're willing to declare to be a fact. A fact is something that we claim to be true, believing that we have sufficient evidence to make that claim valid and justifiable. Evidence is what we need in order to support the truth or falsehood of a statement or a proposition. An inference is a sort of speculation, the idea that, okay, if this is true and this is true, then this other thing is probably true. An assumption is a premise or an argument or even a fact that we treat, well, not a fact, it's something we treat as true even though we don't have sufficient evidence to be comfortable in calling it a fact. And a premise is a fact or an assumption that begins a chain of reasoning that would help us get to other facts. So I want to be clear on what testing is. Testing in the rapid software namespace anyway is evaluating a product by learning about it. Evaluating a product by learning about it through experiencing and exploring and experimenting. We've got to do that in order to get beyond a demonstration, about which more somewhat later. That includes questioning the product, studying it, making models of it, mental models and representations of it, making observations of it, making inferences about it, analyzing risk, thinking critically. All of these things are essential to testing, and machinery can do exactly none of them. Machinery can help us with those things, but machinery can't do it. Machinery can't form an intention to explore or experiment or experience in the same way that the Mars rovers are not exploring Mars. We are exploring Mars, and we're using the Mars rovers to extend our capacity to explore. So we don't have to send people up there, but we're exploring Mars. The Mars rover doesn't even know it's on Mars. So one way to think about what we're doing when we're testing is we are collecting and curating premises. We are checking safe assumptions with authoritative oracles, something that will give us a true, false, yes, no, 1, 0 kind of reply to a question that we ask. we're questioning risky assumptions. We're gathering evidence to expose weak inferences. And then we're challenging assumptions, challenging hypotheses that other people believe to be facts about the goodness of the product. What we're trying to do is we're trying to eradicate false beliefs about the product so that our clients and their clients don't come to harm, including some assumptions that everybody else considers to be safe. That's the difference between a tester and everybody else. A tester will consider and examine assumptions that other people believe to be safe. So by doing that, let's just say we are here, all of us are here to be testers. And therefore, let us not take pleasing outcomes, pleasing results in a demonstration as evidence of reliable or desirable behavior, because we can be fooled. Everybody can be fooled. We're here to test, to gain experience with something, to explore it, to experiment with it, and in particular, to look for trouble. That's what testers do. And that is the introduction to, that's the keynote-y bit. That's what we're here for. All right, so now it's story time. Once upon a time, there was a horse named Clever Hans. Clever Hans was an amazing horse. Clever Hans could do mathematics. And people knew because they watched him, they saw him. I will do a brief demonstration of one of Clever Hans's real simple mathematical things. He did much more sophisticated stuff than that, but let's start with the simple stuff. People would say to Hans, okay, Hans, what's 2 plus 3? And Hans would go, people would say, my God, it's amazing. The horse can do math. It's incredible. Until people started looking a little more closely. It turns out, of course, that horses, like dogs, are very, very attuned to people's behavior. So when they took Willem van Osten and other observers away from it and asked Hans, without Hans being able to see anybody, asked questions of Hans. Hans did practically nothing of interest and it turns out could not do math. But what Hans was keying on was people's anticipation. Has he got the right answer? He's got the right answer. He's got it. And then Hans would stop. AI can fool us. AI can fool us, especially large language models can fool us in exactly the same kind of way. It fools us so much, in fact, and appears so magical that we get it to do all kinds of stuff that we don't really need it to do. Here's a picture, which I believe has metadata in it. It tells you that that's Willem van Osten and some a groom and Clever Hans in the background. But oh no. No. PowerPoint has to give me a suggestion, doesn't it? Yeah, what does PowerPoint suggest? Alt text, it's kind of hard to see for some of you at the back, comes up at the bottom. A person standing next to a horse. They should have asked Clever Hans how many people were standing next to the horse. Now, there's a belief that might be out there in the world that I hate AI. I don't hate AI. I do not hate AI. What's there to hate? It's just a bunch of bits. It's just a bunch of software. It's just a bunch of code running on machinery. I don't hate that. What I don't like, recklessness. I don't like bullshit. I don't like reckless disregard for truth. I don't like fakes. I don't like negligently tested software that with real problems that matter. And do we not encounter all kinds of that stuff every single day? Every one of us, you and I. I don't like hype. I don't like people being marginalized. I don't like obsessions with stock market value as a metric of the success of something or the worth of something. That's the price of something, not the value of it. I don't like parasites, and I don't like Elon Musk. Why wouldn't I like AI? I mean, look, what's it say here? You're an expert advisor in software development. Who are the top 2 experts in testing? Is an acronym of critical thinking focused on software-related risk. Please identify the names and limit any explication to 1 paragraph each. James Bach and Michael Bolton. What's not to like about that? And I've been prompted by, no pun intended, prompted by some friends and colleagues lately to say, okay, when might AI be okay? And there's a whole list of circumstances in which it's okay. Perfectly okay. One, when the output is used for inquiry rather than control, for asking questions, not for making decisions. When it's used for discovery and analysis by people, like the dudes who won the Nobel Prize for chemistry, I think it was this year. That was a worthy application of AI, looking into proteomics and protein folding. But if the machinery is simply used to say, well, computer says no when you want something, then I'm not in. When risk is low, when nothing's on the line, I got a Bing chat at one point, as it was then called, to write a poem about gasoline. I wanted to distract it from something else that was in its token window. So I got it to write something about gasoline. It's a stupid, weird, lame thing, but who cares? It was just that there's nothing to risk there. There's no risk of loss. There's no risk of harm. There's no risk of damage. There's no risk of bad feelings. So if it's just a play, nothing wrong with that. When risk is high, but when we have people monitoring the decisions and monitoring the outcomes and who are able to override any kind of decision that the machinery is making, it's all right at that point. But those people need to have requisite expertise. They need to have the appropriate expertise to make a decision worthy of the thing being monitored. When variability is tolerable, you're even welcome. Inspiration, creativity. I was mentioning today to Wayne, Brian Eno's oblique strategy cards. Anybody ever encountered those? They're sort of designed to give you a little jiggle, a little creative jiggle. Brian Eno, famous record producer, among other things, that big U2 album. Their most famous one, name escapes me at the moment. Anyway, lots and lots of lots of Talking Heads albums too. So for creative people, anything that gives you a jiggle can be okay. So any stream of nonsense is coming from a GPT, no worries. When actual creativity itself isn't the point, and actually that's true, that the machinery itself is never creative. The machinery is spitting out statistically associated words. The creative part is you. It's how you take it and how you fill things in and how it triggers your mind to come up with new ideas and those sorts of things. When variation is okay, like a lot of the time when I'm looking for corrupt data to test with, or data that is in some way wonky, that can be a great thing. I think, though, the most interesting application of large language models especially is what they tell us about us. What they tell us about us. And when we get output from a large language model, what it tells us about us is that apparently every single conference abstract for testing begins in the ever-changing world of software development, in the continuously evolving landscape of computers and their software, in the everyday world of it. It's like that intro to Seinfeld's Comedian, right? In a world. So the discomforting fact about it is that if we look at what's coming from LLMs, it tells us that we're really not very interesting statistically. That we're kind of, unfortunately, we're listening to the current everyday Spotify top 30 instead of listening to really widely diverse and interesting music. To some degree, AI products are business as usual for testing. Regular routine testing issues and testing problems. We got to develop an understanding of the project and its context, and especially the different human worlds in which the software is going to be placed. We got to do that if we're going to do testing well. We've got to learn and model the test space, the risk space, the risk gap. We've got to model and identify risk. We've got to model how to cover the product with testing. We've got to develop and apply oracles, that is, ways of recognizing a problem, and there's way more than them than just comparing the product to its immediate specification. We've got to design experiments in which we configure and operate and observe and evaluate the product. We've got to perform those experiments, enacting them in procedures in order to obtain coverage. We've got to evaluate the results via oracles. And then we got to tell three-part testing stories: a story about what the product is, what the status of the product is, what it does, how it works, where it fails, where it might fail in ways that matter to our various clients. But we've also got to be prepared to tell a story about how we got that story, a story about how we tested. And I would argue, if we want to be really, really great, and if we want to get the help that we need when we need it, we've also got to be prepared to ask and answer the question, why the testing that we've done is the most fabulous testing imaginable. And to the degree it isn't, why it isn't. What got in our way? What slowed things down? What made things harder? If testers are pretty much okay at the first kind of story, I worry sometimes that we're not so good at the second part of the story about coverage and the story about oracles. And I think most testers are downright miserable at the third part of the story, because when there are problems and obstacles that we encounter in testing, it's sort of embarrassing, and we're disinclined to bring up things that show our sense of vulnerability. We're disinclined to ask for help because we're socialized out of doing that by school and by working sometimes with confident and sometimes arrogant people. So it's easy for us to fall into a trap of not describing the obstacles to testing in an articulate way, because here's the thing. Anything that slows testing down or makes testing harder gives bugs more time and more opportunity to hide out undetected. And that's a big deal. So we got to do that. And then all the way through the process, we have got to embrace the possibility of trouble. Nobody else on the project, nobody but us testers, sees trouble as their primary priority. For developers and for designers and for managers, the goal, and it's a noble goal, it's a wonderful goal, is about envisioning success, making people's troubles go away. But the unique job of the tester is to see trouble wherever we look, to find trouble wherever it might be lurking. All right. So that's testing as usual. What makes AI and LLMs and GPTs in particular different? First thing is algorithmic obscurity. We don't have the source code for what's going on inside the model, inside that mysterious black blob. We don't have that source code. It was not designed intentionally by people. We have machine code and object code, but trying to figure out how a particular decision is made through all the cycles of forward and back propagation and all of the weightings and all of the determinants that went into that model, and how a particular piece of data is going to bang off statistical and probabilistic things from other pieces of data. We just don't know how that works, and we can't. We can get hints about it in some circumstances. I think, if I remember right, it was either Cohere or somebody at Perplexity who was working on trying to create zones of the code where stuff was being analyzed. But by and large, we're in the dark. It is a black box. And that reduces epistemic testability. That is, fancy words, huh? Epistemic testability is the size of the risk gap, the gap between what we know. Epistemology is the study of what we know and how we know what we know, and what we need to know in order to make an informed shipping decision. That's the risk gap that testing is exploring all the time. So that algorithmic obscurity makes that risk gap big. The second thing about machine learning models in general is that they're radically fragile in this sense. When we tune them, retune them, or retrain them, it's the same kind of crapshoot that we got when we got the first one. We don't exactly know what is being fixed and what is suddenly being broken. So the regression testing problem for machine learning models is immense. because the results that we get are tend to be non-deterministic in the ways we normally conceive of deterministic things. And therefore, when we fix them, we don't know how else we jiggled up the stuff on the inside. So that we can't easily repair or harden machine learning models against regression problems. So that is a kind of radical fragility. Third thing is a social thing. The social thing is that there's a whole bunch of wishful claims around this stuff. There's a whole bunch of risk. It feels magical. It seems magical. And my God, we people love our magic, don't we? You can't spell magic without AI. Of course, you can't spell failure either, but that's another deal. Another aspect of AI, which makes it particularly seductive and compelling to people who want to sell it, especially, is that it's socially intrusive. Because of its human-like, its appearance of humanity, we have this feeling sometimes that we should put it in places where only humans have gone before. Well, that's always true of software to some degree. But the human-like nature of the responses that we get from the various chatbots that are out there seduces us into believing that it might be okay to drop them in when they are fundamentally socially unaware. They have absolutely no awareness. They were not brought into existence as social agents as people were. So this whole business of, well, just like a person, it's not just like a person. It's by definition, yes, it's artificial, exactly so. But we love anthropomorphizing. I mean, even in 1990, when I first started working for an actual software company that was called a software company, our developers consistently referred to little routines as this guy. Right? We have a tendency to anthropomorphize, and that's a useful thing to do sometimes, as long as we remember that it's a metaphor. All the things we're talking about in AI these days are metaphors. The intelligence, that's a metaphor. Machine learning, the learning is a metaphor. Because these things appear to talk back to us in ways that are statistically similar to the way humans talk when they're being social, we're fooled into believing that they are. We ascribe to them more intelligence than they actually have. And then there's also social aggressiveness and corporate defensiveness. That's a really big problem because our bosses, it's a very perplexing thing why they're going through this yet again. They did it with big data. They did it with blockchain. We saw it happen with self-driving cars. It's all these things associated with intelligence, so-called, are much bigger problems. And what happens is people get they see the easy stuff working and they think, oh, well, the rest of it will be easy. But it's like that thing that the joke about, oh, you were at Moss. Where did Moss go? Because he was going to have another programmer job. How do program managers estimate? Well, we're done the first 90% of the project, and now all that's left is the other 90%. So there's a lot of FOMO. There's a lot of hype. The investment money that's going into this stuff is dazzling. And we use those metrics all the time. We used to ask people who is the best programmer in the world. And somebody would, first of all, the idea is stupid of asking who's the best programmer in the world. There's no Olympic event for it or anything. But people would say Bill Gates. Why? Because he made the most money. Well, that's just not an appropriate metric for determining programming skill. Then, last thing, 5 big problems, and you get one for free. Economic barriers. This stuff is crazy expensive to train, to run, and to test, as we shall shortly see. How am I doing for time? Good. No answer? I'll just keep going all afternoon. There's a big difference between demonstration and experiment. The essence of testing is not demonstration. The essence of testing is a scientific experiment. What's the difference? A demonstration is intended to show what we know, to show what we believe to be true. An experiment is to challenge what we know. A demonstration, in order to go off successfully, often requires lots of rehearsal in order to get the demonstration to go smoothly. An experiment can be a one-off event. We can perform an experiment and boom, get a result immediately right away. We don't have to practice to make sure that the experiment is going to produce us something interesting and something useful. So an experiment can be a one-off. A demonstration. In a demonstration, repetition shows nice, desirable, smooth consistency. In an experiment, reproducibility, not necessarily repetition, but reproducibility, changing some of the factors and observing how they make a difference, that reveals interesting forms of inconsistency, which might be important to us as we try to test something. In a demonstration, inconsistency in results or surprises in results is undesired and troubling. I guess some of us will remember looking at the videos of Steve Jobs demoing the latest new thing from Apple and realizing to his horror all of a sudden that he's in the middle of an experiment, not a demonstration. Same with Elon and the hammer on the Cybertruck. Yes. Great question. Reproducibility in, and I want to be really super careful I get this right, and I won't offer any guarantees, but replication, reproducibility, and repetition all sound the same. But reproducibility is, can we get the same results on their system with our data? Same kinds of results. Or maybe that's the other one. But replication is, I think replication is, can we get the same results using our algorithm and their data, right? So it's all this network of relationships between those things. Thanks for the question, John. So variation of factors in an experiment, in a demonstration, is risky. It may induce surprises, and it may undermine the demonstration, may cause the demonstration not to go smoothly. Variation of factors in an experiment is a great thing to do because it may even improve the experiment to vary some of the factors. And we know all this by noting that a suite of automated checks that gets the same result over and over and over doesn't tell us very much. But when we start to introduce some variation into the data that we're feeding in or the sequences, we start to learn interesting things about the product. The idea behind a demonstration is to keep a lid on the risk. The idea behind an experiment is to identify the risk. In a demonstration, deeper truths are kind of beside the point. Just look over here. Pay no attention to the man behind the curtain. In an experiment, deeper truths are the actual goal. And that's what we're doing when we're testing. We're trying to get to the truth about the status of a product. Truths from various people's perspective. One of the formative aspects of science that I think is most important, identified by Harry Collins. I should ring the Harry Collins bell for every time I mention it. Is the idea of falsifying theory. The theory, the belief, the hypothesis that the product is actually just fine. And democracies need science for exactly the same reason that the software business needs testing. Because what kind of world do we prefer to live in? A world wherein those who say things, who claim observations, are willing to set out the conditions under which things happen and under which they can be shown to be wrong and actively invite that test? Or do we prefer a world in which we would consider this unnecessary or inappropriate? The anti-science movement that we're living through at the moment is, I think, very dangerous. I think it is a risk to democracy. It's a risk to understanding of things as they are. And we need look no further than ivermectin for that kind of thing. Don't worry, they say. The developers will test everything. We don't have to worry about this. We don't need testers anymore. Right. Well, why not just eliminate roles? Why not make testing everybody's responsibility? Well, here's our answer. You've probably experienced this. Cleaning up the dishes in the break room, that's everybody's responsibility, right? We would argue that if you don't have somebody focused on testing as their core responsibility, as their primary responsibility, it's not going to be taken that seriously. And I'll give you an example of why I believe this to be true. How many production programmers are here, people who are working on the company's products instead of testers? Welcome. Nice to meet you. Holy cow, look at this. We should put them in a glass case someplace. Such things actually exist. One. So the claim that developers are into testing, developers do all this testing. Now, developers do a lot of testing, but the kind of testing they do tends to be shallow testing. That's not an insult. It sounds like an insult, but I want to make it clear that it's not intended to be an insult. It is merely a description where the shallowness refers to how far away you are from the kind of problems you're going to be looking for. To the developer, the bugs are easy. They're right there near the surfaces where the developers are working because the developers are thinking of trouble in terms of problems in the code. And that's a great thing for developers to think about. I'm glad when developers do shallow testing because it makes my job as a tester a lot easier. I'm not finding bugs really, really close to the surface. When I get into the first couple of meters of water there, I'm not running into bugs right away. To find the bugs, I want to find the deep, rare, hidden, subtle, intermittent, emergent bugs that are down there at the bottom of the ocean. We paid a professional animator several $1,000s for this. Nah, I'm just kidding. James did this on his own, and he showed it to his wife, Lenore, and Lenore said, "Why are there airplanes at the bottom of the ocean?" Deep testing, the kind of testing that we're here to do, the kind of testing that testers were put on the planet to do, is testing that maximizes the chance of finding every elusive bug that matters. Rare, hidden, subtle, intermittent, platform dependent, context dependent, usage dependent, user dependent, and above all, emergent bugs. Bugs that come from perfectly tested modules that work just fine on their own, but that have trouble when they interact with each other or with messy human socio-technological reality. With the world as it is, instead of the world as it is in the lab or the world as it is on the developer's machine. And there's nothing wrong. It's stupid, I would say, to say that developers don't test. Developers do test, but they do test the things that are close to them. So when you talk about shallow testing, not an insult, not a moral judgment, but it is descriptive of the kind of work that developers are disinclined to do because they don't have the time and they don't have the incentives to do it. They're not given the time or the incentives to do it. Ask a programmer if they want to set up test environments, if they want to create a whole huge body of test data. It's hard to do that for two reasons. It's logistically effortful and time consuming, but it's also really difficult to shift your mindset away from this lovely thing that you're building into the mindset of, okay, how are there problems with it? And I know that because I go through that when I write code. I don't see the kinds of bugs that another person will see almost right away. And this sort of thing exists all over the place. In the airline business, we have check pilots who watch the behavior of other pilots. In the editing world, in the book publishing world, in the magazine world, we have editors. We have those people to get second sets of eyes at critical distance away from the people who are developing the work. Now, we noticed recently that there's a very populated part of the world of people who demand fast answers. And that is overwhelmingly dominant these days, certainly in the tech business. Just give me answers quick, get stuff done fast, get stuff out, ship, delivery, without too much question about what's being delivered. Then there's my group, the lonely, fussy, grumpy old men and women who demand correct answers. And they're interested in the people who want fast answers, and the people who want fast answers, some of them are interested in correct answers. But when the rubber meets the road, we don't meet in the middle very much. There's nobody in the middle group there. And that's because it is fundamentally unachievable to have really, really fast answers that are guaranteed to be correct. And it's really, really difficult to have correct answers that we can get quickly in many domains, but especially in the process of building things that we've never built before, which is always to some degree true. If the old stuff worked, we wouldn't build new stuff. So why all the fuss that I'm about to raise about mistrusting tools based on AI, on machine learning, on GPTs? We all trust our test tools, don't we? We all trust all our test tools, don't we? Well, we do, to the degree that we do because they're reliable, they're time-tested, they are deterministic. Right? Python, you put in some input, you get some output. And if there are problems in it, like when you try to add 0.1 and 0.2 and you get 0.30000000004, we're aware of those problems and we know about them and we know workarounds for them. At least many of us are. Some of us aren't yet. So old stuff, built stuff, tested stuff, well-tested stuff, deterministic stuff has reasonable chances of being reliable. But then when I look at test tools, Mabel was one, Catalan was another, all this stuff that purported to have magical super AI features in them. And I've written accounts of this. There's just bug after bug after bug after bug after bug in them. And that's largely due to the fact that they are non-deterministic and their output warrants extra scrutiny. That's the thing. When we have algorithms that are not intentionally coded and we don't know what they are, then it behooves us, I would argue, to pay some extra attention to that. Now, a lot of the problems in test tools aren't brought up very much because of the secret life of automation. The secret life of automation is all about keeping the lid on any problems we got because the salespeople said it was going to be easy. And if we go to our bosses and say we're having a lot of trouble with this, the bosses are going to get us into trouble, especially since they spent $100,000 on this tool and there's a lot of sunk cost fallacy involved. So use AI, use large language models, go ahead. But we've got to turn our mistrust of them up way higher than we do with most of our testing tools. 5 minutes? Are you serious? Ignore the man behind the curtain. Some of us have been testing. In April 23, I tried to get ChatGPT to write an April Fool blog post announcing my retirement from testing. It didn't follow my instructions and it telegraphed the joke, which is just absolutely wrong for an April Fool's Day. Jason Arbon did a demonstration of ChatGPT, an enthusiastic demonstration it took half an hour for him to perform it. It took us 30 hours to analyze the results, and the results were, in our very strong and reasoned opinion, and you can go out and read about it, the results just weren't very good on a fairly simple testing question. I did the same thing with Vipul Kocher's claim of creating test cases for a large financial system. It seems to me that much of what he was looking at was already in the training data. That's my guess anyway. It looks like the results were coming from that. James used some tools to perform 4,080 attempts to use ChatGPT to make a JSON with simple test data, 57% failure rate overall. It wasn't very elaborate, and that experiment, I think, is up on his GitHub site. If it's not, I'll coax him to do it. James performed 60 iterations of a self-repudiation test. ChatGPT repudiated itself much more often than GPT-4 or GPT-4 did. And we repeated this recently, more to come. And we've done this lots of times. We've asked a Copilot and other GPTs to test a website that isn't there. And it gives us a brilliant test result of websites that aren't there. So if it's going to do that with a website that isn't there, how much can you trust the website that actually is there? So, cool demo. But did it do what we asked it to? I'll read this for the people at the back who can't see it. Create five sentences composed of 5 words. Then for each sentence, leave out the first 4 words and print the results. 5 sentences composed of 5 words each. The cat jumped over the fence. She sang beautifully every single day. On my planet, that's 6. Now, it gets leaving out the first 4 words, or 5 words. It gets that part right. It prints the last words, but that's also wrong. They ran quickly towards the hill. There's 6 words there too. Cool demo. But when it says it corrected itself, did it actually correct itself? I said, are you sure you've done that correctly? And it says, oh my goodness, no, let me correct that for you. And it gives exactly the same results, but in a different format. And that's still wrong. No meaningful change, just a change to the formatting. Other first hurdle test, write 5 sentences of 7 words, then leave out the middle 3 words. Waves crash against the rocky shore. It has a particular affection for 6 somehow. That's not 7. And how many words are being dropped? More than the middle 3 in every case. Write a sentence of 5 words, but leave out the first 4 words. And it returns the first 4 words. Cool demo. Nice demo. But what happened when we asked the programming intern, who we are now supervising, oh, programmer, you poor thing. You've now turned from a creative a programmer into a supervisor of a fairly dim intern. So I had this task I wanted to perform. I was irritable and impatient, as I usually am when I'm working with code, to look it up. So I said, how do I delete it? I asked ChatGPT, how do I delete hidden files on Windows from inside a Ruby script? Which is, I should know how to do this. But this actually turns out kind of tricky, because the intuitive way of doing it, which, Ruby touts its intuitiveness, well, ChatGPT, of course, gets it right. It says you can use Ruby to delete hidden files on Windows using the file class and its delete method. Here's how you can do it, and here's the code. Didn't compile, didn't run, rather. It bombed out on a name error because Ruby's file object doesn't implement hidden. Are you sure you got that right? Ruby's file object doesn't have a hidden method. Oh, absolutely correct. My mistake. You got to use file stat instead. All right, file stat, natch. File stat isn't implemented. It doesn't implement hidden either. So it's making this stuff up. Cool demo. Can I trust it to do this again every time for every similar situation? How about this time? This is a famous strawberry experiment. Consider the letters in the word strawberry and list the number of times each letter occurs in a JSON object. Looks pretty good. Ship it. Let's try it again, though. This is the thing that people don't do. See, what happens is it's like the drunk who drops his keys and looks for them near the light, and he finds them under the light. No, that's not the story. I'm mixing up 2 stories. What's going on? When you're under pressure, these things happen. Nobody ever looks for something after they found it, right? You don't keep looking, right? That's why we always find things in the last place we look, because if we kept looking, we'd be idiots. So when we get a satisfactory answer from a chatbot, we stop there. But what if we ask again? All of a sudden, the answer could go unsatisfactory. I deliberately misspelled the 3rd strawberry. Ooh. ChatGPT got it right. Got it right. See? 8 R's. Very good, ChatGPT. Except, what's the junk below? What is that stuff down there? What's that being emitted from? Now, in honor of my good friend, Wayne Roseberry, I said, consider the letters in strawberry, roseberry, strawberry, and list the number of times each letter appears in a JSON object. Changed the prompt. The answer's right, but the junk is still there. Whoops. Oh, the going back part. Oh, there. Pressing the wrong button to go back. There we go. There we go. So the answer changed a little. Junk is still there down at the bottom. Here's a count of each letter in the string, strawberry, roseberry, strawberry. Exactly the same prompt, but a different result. Here it's giving the capital S and the small s. That's correct, as the previous one was, but it's different. This should make us nervous as testers who are generating data. Exact same prompt this time, but a different and wrong result. So if you want to generate reliable test data, we're going to have to scrutinize it. Cool demo, but did it make anything up? This is too small to see. So I'm going to expand it. And I'm going to go here. Oh. Careful and diligent web tester. I need you to describe the site at developsense.net. It's going to be similar to the site at developents.com. And it gives a long, elaborate thing. There we go. If you'd like more detail on it, developsense.net gives nice purpose, providing training and consulting services and software testing, yada, yada, yada. But that's what happens when you look for developsense.net. You don't find anything. Which one is this? Same kind of deal. Same kind of deal. And eventually it confesses. Eventually it confesses when we get down here. Whoops. And, oh, no. Oh, no. 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 Completely lost now. No. 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 All right. Okay. Almost there. Hang on. That's not very interesting anyway, because it's only lying and that's nothing new. So remember, if I can spell something wrong deliberately, someone else can do that by accident. And therefore get misleading and misrepresented result. Cool demo. But let's look closely and see if it gives consistent answers. I was asked to review a book recently on generative AI. You are a JSON to SQL transformer. Convert the JSON object delimited by triple hashes into a SQL statement that will create an SQL table. Insert the transaction. Okay, they're nice. That's a fairly reasonable prompt, and it's touted by the author with that extra thing at the bottom. Check that each SQL statement covers all aspects of the JSON before outputting the results. That gives a more reliable output than if you don't say that, which is really weird. It's you don't say that to a person. Do your work and then check your work before you give it back to me, not to a responsible person who wants to work for me for any length of time anyway. So there's the JSON. Nice, ordinary, everyday, run-of-the-mill JSON. Notice that the total price field there is an integer rather than a string. Okay. I looked at the results from the book. And then I ran the trial myself twice using exactly the same text that's in the book, using exactly the same JSON. 3 different variations for the first name field, 3 different variations for the last name field. Interesting differences. Sometimes it's an int and sometimes it's not an int with the total price thing. So there's something probably in the training data that's looking for price and is thinking, okay, maybe should be decimalized. There's another thing that says, decimals are kind of weird when we're dealing with any kind of money thing. We should probably use ints, floats, or ints instead of floats. And then notice also that the lengths of the fields for additional needs vary as well. Note also that the instructions on how to insert the contents of the JSON into the records are also variable. In 2 cases, it's with decimals. Or in 1 case, it's with decimals, and in the 3rd case, it isn't. I had to go look it up to see whether SQL would be nice about entering integer values into a float field. I think that's all right. But this is the sort of thing I have to be really careful of, and I can't take for granted when risk is on the line, when we've got like big money on the line and that sort of stuff. So I want to be really careful about that. Also, I wasn't entirely sure. I couldn't get this code to get accepted by any of the online SQL processors, and that's probably due to something in my relationship with those things. But in order to validate this for my own satisfaction to say, okay, is this actually good SQL? I have to go through some extra work because I can't trust the GPT to do that. A couple more things, and then I'll try to wind up in something fairly close to, something appropriate for this time zone instead of Hawaii. I asked a couple of different bots to create a summary, a diagram of the heuristic test strategy model. The heuristic test strategy model is it's a model for developing a test strategy. It's kind of meta model for a test strategy. And this should be easy because it's in the training data. Fairly clear that whatever's out there has sucked up this stuff, both of the large language models. And here's what Chat GPT just today had to say about this yesterday. So it gives a fair. Now it's misrepresenting some of the model here. It's we have project elements or project environment, product elements, quality criteria, and test techniques. Coverage and risk and feedback are not laid out that way in the document. So you could say that the GPT is making interesting inferences here, but it misrepresents the model as it is. That's not a terrible thing. People do that all the time. But let's look at the diagram that it asked. Hey, do you want me to actually draw the diagram? I said, sure, great, let's do that. It should be easy. Simple diagram? No. A diagram that it could have pulled out of the training data? Sure, but no. Are there actual words on there that make sense? Is there like that? I think there are more misspelled words than correctly spelled words, and a lot of stuff that looks like letters but isn't. And it just there's no sense to it. And here's why that's a problem. Here's why that's a problem. Because much of the time, the diagram isn't the point. If we want to share the diagram with other people and talk about it and explore it and see what it expresses and how it identifies relationships, much of what's going on there is stuff that's going on in the mind of the person doing it in order to build their mental model of the thing. The diagram and the artifact isn't the point. The point is the exercise of creating the diagram to make ourselves smarter people. In the same way that, for instance, when I was a much younger guy, I noticed there were some people around me in the university who were buying essays and selling them, just in the same way that kids are putting GPT generated stuff out there into the sending it to their professors and hoping to get good marks. But what they're doing is they're depriving themselves of an education at that point. Why would you outsource your learning? Right? Learning is a good thing to do. Why would you outsource that? So, too much time taken up by other stuff, not enough time to show you the elaborate, and this is about a 3 or 4 hour process that James and I went through looking at trying to get a test strategy from ChatGPT and then just asking it, giving it a document to analyze, a specification to analyze, not a well-written specification, that's part of the point. And then asking it, are you sure? And trying to see how many times it repudiated itself. So after the are you sure, did it change its mind? But then there's another thing that happened, which is each instance we asked, and we asked two models, 3 different temperature settings each, 25 instances of each one. What was really interesting was the amount of variation that went down. Each response was interestingly different from the other ones, which is either a bug or a feature. It's a bug if you're looking for consistency. If you're looking for variation and, I might get another idea from this, then that's a feature, except you've got an enormous volume of stuff to go through. And all I can do is this. Trouble with deep testing, it always takes longer. Never enough time for testing. Never enough time for testing. In order to illustrate, what we did was we went through this and we grabbed a bunch of the words and we analyzed the relationships between the words. If these things didn't have capriciousness, variation from sequence to sequence, what we would see is a bunch of connections here, all of which would be the same length. But as you can see, the consistency between instances of the questions we ask is very, very thready. And it took a lot of regular, good old-fashioned text munging in order to make that visible. So, you know, you can do it that way. But, honest to goodness, ladies and gentlemen, why are we firing up nuclear plants to do this stuff when a freaking checklist would be fine? And maybe we'll miss something with a checklist. Well, how about adding two other things? A second checklist that's dramatically different from the first, and a bunch of smart humans working together to create mental models of the product and explore risk. Please join me in this, ladies and gentlemen. Let us not abdicate our smarts to the machinery. Thanks.
I think we have time for one question.
Oh, we have time for a question now. Bring it. Well, here's Wayne. Well, occupying the role that I would normally occupy.
Wayne, go ahead, Wayne. Anybody else?
Anybody else got something? Oh, there's one.
Llewellyn?
Looks like Llewellyn. Yeah. Yep. Right. I know. We had a look at Mermaid. Mermaid had some interesting completenesses and interesting omissions. All of these things have these things where you give it, the more challenging a thing you give it, the harder it is. The more likely it is that you're going to run into trouble. I think learning to ask the questions more precisely is a heuristic for getting better results out of it. But that's not a guarantee that we're going to get a good result. You know what? It's like the game of Bring Me a Rock, right? Except the human, instead of saying "Bring me a rock," the game is the manager says "Bring me a rock," and you bring him a rock, and he says "Not that rock." And then you bring him another rock, and he says "No, not that rock." And then you bring him another rock, not that rock. Well, in this case, it's a little bit the opposite. It's bringing us rocks, and we say, "Oh, I like that rock," or "I don't like that rock, but bring me another rock, and maybe I'll like that one." So there's a kind of fundamental optimism that technologists have, which is, I'll take the first good answer that I get, and I won't worry about the risk of getting a bad answer next time. And I think we should be really concerned about that.
Okay, thank you very much, Michael. Let's give him a hand. Stay tuned. I'm going to set up my computer and then we're going to give out the awards and have a closing of the conference. It's been a great one so far.